Hello everyone. This video would focus on conic section, specifically on hyperbola with center at 0, 0 or at the point of origin. And this is the fourth part. In this part, we're supposed to determine the standard equation of the hyperbola given the two vertices and the two foci. Before we go further, please feel free to check out the description box below for the link of the other series of topics related to hyperbola. Before we jump into the example that we have right here, let's have a review on the parts and the two cases and the equations of hyperbola. Please notice that this hyperbola is called the horizontal hyperbola because the graph, which is in red, which is the hyperbola, is touching the horizontal axis. Now, these are the parts. The first part is the center. The center is located at 0, 0 or at the point of origin. Another part is the vertex. There are two of them. We call them as vertices. Another part is the transverse axis. The transverse axis is the line that connects the two vertices passing through the center. Another part is the co-vertex, and there are two of them. We call them as co-vertices. Another part is the conjugate axis. This is the line connecting the two co-vertices passing through the center. The next part is the focus. There are two of them. We call them as foci. Please remember that the focus is located to the side where the hyperbola or the branch of the hyperbola opens. Another part is the latus rectum. This is the line segment with endpoints on the hyperbola and it passes through the focus, and there are two of them for each side. The next part are the asymptotes. These are the two lines that form an X shape where the hyperbola approaches but never touches it. We call them again as asymptotes. The equation of the asymptote with a negative slope is y equals negative b over a x, while the other asymptote with a positive slope is y equals b over a x. Now, the easiest way to draw the asymptote is by drawing a rectangle covering the 4 points, the two vertices and the two co-vertices. And the two asymptotes are actually the diagonals of these rectangles extending outward of the rectangle. So that's a trick on how to approximately draw the two asymptotes. Now let's look at some important lengths of hyperbola. The first is the distance from the center to the vertex is represented as letter A. The distance from the center to the co-vertex is represented as letter B, while the distance from the center to the focus is represented as letter C. From here, we can go ahead and say that the length of the transverse axis, that is from one vertex to the other vertex, is a formula of 2a, while the length of the conjugate axis, that is from one co-vertex to the other co-vertex, is 2b. Now, the equation that relates all these three lengths here, A, B, and C, is C squared equals A squared plus B squared. We also have another quantity called eccentricity. Eccentricity is defined as the measure of how oval the hyperbola is. And the formula for the eccentricity is C over A. Now, we remember that eccentricity for a hyperbola is always greater than 1. Now, the standard formula for a horizontal hyperbola is x squared over a squared minus y squared over b squared equals 1. Now, please notice this. Since our A is on the horizontal axis, we therefore placed it under the x squared. And since our vertex is on the horizontal axis, the x squared over a squared is positive. Now, let's look at the second case of a hyperbola, which is the vertical hyperbola. In the vertical hyperbola, we still have the same parts. And the equation of the asymptote with a negative slope is y equals negative a over bx, while the one with a positive slope is y equals a over bx. We also have these lengths in a vertical hyperbola. We also remember that the standard formula for a vertical hyperbola is y squared over a squared minus x squared over b squared equals 1. Now, please notice that our vertex is on the vertical axis. That's the reason why our A is under the Y. Remember, Y means up or down. And that's the reason why the A squared is located under the y squared. Now, we also remember that our y squared over a squared is positive because this is a vertical hyperbola. So these are the parts, the two cases, and the equations of a hyperbola with center at 0, 0 or at the point of origin. Okay, going back to the problem right here. So we are given the two vertices of the hyperbola. So we can go ahead and plot these points right here. So that is at 0, 5. So it's going to sit right here. This is our first vertex. And the other vertex is located at 0, negative 5. This is the other vertex right there. We also have the coordinate of the two foci, that is 0 square root of 34 and 0 negative square root of 34. So we're going to change this square root of 34 to its decimal version. And this is how it's going to look like. Okay, so the decimal version for square root of 34 is approximately 5.83. And so I plotted the two foci right there. Now we remember that the center of the hyperbola is the midpoint between the two vertices, or the midpoint between the two foci, or the midpoint between the two co-vertices. So looking at this, we can go ahead and say that our center is at 0, 0. So this is our center right there. Now looking at this further, we see that the two vertices that we have here are vertical relative to each other. So this hyperbola that we have right here would be an example of a vertical hyperbola with center at 0, 0. So I'm going to go ahead and write that up here. Since this is an example of a vertical hyperbola, we go ahead and say that the general equation for a vertical hyperbola is y squared over a squared minus x squared over b squared equals 1. So we need to determine the values of a and b so that we can go ahead and complete this equation that we have right here. Now we remember that this value of a that we have here is the distance from the center to the vertex. So looking at this, we can therefore say that our a is 5. So counting from the center to the vertex, 1, 2, 3, 4, 5, or you can use the distance formula for this. But just counting it, you can get rid of the distance from the vertex to the center, and that is 5 right there. So we can go ahead and plug that in here. Now, if you notice, I left the b squared blank because we don't have the b value. However, this value from the center to the focus is our c. So that we can go ahead and use the equation c squared equals a squared plus b squared to determine the value of the b squared. So I'm going to go ahead and write that work up here. So looking at this, the distance from the center to the focus is square root of 34. So we can go ahead and write that up here, that the distance from the center to the focus, which is represented as letter C, is equal to square root of 34. So I go ahead and plug that in here. So that is square root of 34 squared equals our A was 5. So we plug it in here. 5 squared is equal to b squared. From here, we can go ahead and solve for b squared and plug it in here. And so we can get the equation of the hyperbola. So square root of 34 squared is 34 equals 5 squared. So this is supposed to be a plus right there. 5 squared is 25 plus b squared. We wanted the b squared by itself, so we're going to subtract 25 from both sides, so minus 25. So then we are left with b squared is equal to 34 minus 25 is 9. So that is equal to b squared. This tells us that our b then is the square root of 9, which is plus minus 3. So then we can go ahead and add that up here. So our b is 3. So we can plug that in here. 3 squared would be 9. And so the equation for this hyperbola would be... So this is the equation of this problem that we have up there. Now we can go ahead and plot our b here. Remember that the b is the distance from the center to the co-vertex. So from the center, I go 3 to the left and 3 to the right. So this is our first co-vertex, and the other co-vertex would also be 3 places to the right. So this is the other co-vertex. So that we can go ahead and write the coordinates of the two co-vertices up here. Okay, so we're now ready to draw the rectangle that covers the two vertices and the two co-vertices. I'm going to go ahead and draw that up here because this rectangle is going to help us write the asymptote or draw the asymptote and eventually draw the hyperbola. Okay, we're now ready to draw the asymptote. We remember that the asymptote passes through the opposite corner of the square passing through the center. So I'm going to go ahead and draw those two asymptotes right here. Okay, now the equation for these two asymptote would be, so we start with the one with a negative slope. Again, we have a formula to determine the equation for the asymptote, but in order that we don't have to memorize all these formulas, this is the trick. From the center, we go up to the corner of the rectangle. So I go up 1, 2, 3, 4, 5. So that is equal to y equals 5 over. I go to the left 1, 2, 3 to the first corner. So that would be negative 3 because I went to the left and then just put x next to it. So this is the equation of the asymptote with the negative slope. And the equation for the asymptote with a positive slope would be, we go ahead again from the center, we go up to the corner. So that would be y equals, we go up 1, 2, 3, 4, 5, over, we go to the corner of the rectangle, 1, 2, 3. It's positive because we went to the right, and that is y equals 5 over 3x. Now we can go ahead and determine the length of the transverse axis and the length of the conjugate axis. Remember, the length of the transverse axis is the length from vertex to vertex, and the length of the conjugate axis is the length from, or the distance from the co-vertex to the other co-vertex. So I'm going to go ahead and write that up here. So the length of the transverse axis is 10 and the length of the conjugate axis is 6. Now we go ahead and sketch the hyperbola. So this is the hyperbola or the graph of this equation that we have right here, and this is the equation of this problem that we have here. Now we determine the eccentricity. We remember that the eccentricity of a hyperbola has a formula. E is equal to C over A. Our value for C here is square root of 34. And our value for A is 5. So this is the eccentricity of this hyperbola. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So we are given the two vertices and we're going to plot this, and we're given the two foci. So what I would do is change, using the calculator, I'm going to change this 2 square root of 13 to its decimal form, and then I'm going to plot this 4 points, the two vertices and the two foci on this graph up here. Okay, now we remember that the center of every hyperbola is the midpoint between the two vertices, the midpoint between the two foci, or the midpoint between the two co-vertices. And so we can go ahead and say that the center between these two vertices is the point of origin or at 0, 0. So I'm going to label that as our center. And since looking at this, figures that we have here, the two vertices are horizontal relative to each other. So they are side by side relative to each other. So we can go ahead and say that this hyperbola is an example of a horizontal hyperbola. So I'm going to go ahead and write those information up here. Okay, since this is a horizontal hyperbola, the general equation for horizontal hyperbola is x squared over a minus y squared over b, that's squared, both of them, equals 1. So we go ahead and determine the values of a and b. Looking at this, remember that our a is the distance from the center to the vertex. So that would be 1, 2, 3, 4, 5, 6. Our a then is 6. So we can go ahead and rewrite this as... Okay, so I kept the b squared missing because we don't know what it is. We only have a. We remember that this focus that we have here is actually having a distance of c, and that is represented as c equals 2 square root of 13, or approximately 7.21. So that we can go ahead and use the formula c squared equals a squared plus b squared to solve for b squared, and we plug it in here. So I'm going to go ahead and show that work up here. So looking at this, we have solved our b as 4, or the b squared is 16. Now, please remember that this becomes 4 times 13 because 2 squared is 4, square root of 13 squared is 13, and that came out 52. So again, our b is 4, so we plug that in here. So this would come out. So this is the equation of this problem that we have up here. Now, looking at this, we have the... b is 4, so the b is actually the distance from the center to the co-vertex. So that means I go up 4 and down 4 for the location of the co-vertices. And so we can go ahead and write the coordinates of these two co-vertices down here. Okay, so we can go ahead and sketch the rectangle and the two asymptotes. Okay, so I have written here the rectangle, and remember that this rectangle should cover the two co-vertices and the two vertices, and the diagonals of the rectangle would be our asymptotes. So the equation for the asymptote for the one with the negative slope would be, remember, we go up. So 1, 2, 3, 4, and then we go to the left 6. 1, 2, 3, 4, 5, 6. That's negative. You can go ahead and change this to y equals 2 over negative 3x. It's still going to be the same thing. And so this is the equation for the one with a positive slope. So we can go ahead and determine the length of the transverse axis. That's the distance from one vertex to the other vertex. And the length of the conjugate axis, that is the distance from the co-vertex to the other co-vertex. So I'm going to go ahead and write that work up here. Okay, so the length of the transverse axis TA is 12, and the length of the conjugate axis CA is 8. Now we go ahead and sketch the hyperbola. Okay, now we can determine the eccentricity of this hyperbola using the equation E equals C over A. So I'm going to go ahead and plug the values in. So our eccentricity is 2 square root of 13 over 6. We can still reduce this to lowest term. There's 1 2 in 2, and there's 3 2's in 6. So we can go ahead and say that our eccentricity is square root of 13 over 3. So this is the eccentricity of this hyperbola. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!